Hello, good morning everybody. This is Ram Mohan. I am working as head of Electronics and Communications Engineering Department, presently placed at Government Polytechnic, Mahabubnagar. The subject we are looking here is the basic electrical and electronics engineering, that is for the first years of diploma students. The topic here is the resistors unit, and the subtopic currently we'll be dealing in this session will be the need for tapering in potentiometers, then rheostats, and also its applications. The objectives of this session are: on the completion of this topic, we'll be able to understand the meaning of tapering that will be implemented in the potentiometers. Then, what is the so we'll be looking at what is meant by tapering in potentiometers. Then we'll be seeing the need for this tapering in the potentiometers. We'll also see the different types of taperings that will be used or implemented in the manufacturing of the potentiometers. We'll also see the working of rheostats, some of the constructions, and also its applications. The previous topic we have actually learned about the different types of the potentiometers. Then we have also looked into the comparison of carbon and the wire one potentiometers. Now let us see what we understand by tapering in the potentiometers. In the potentiometers, the manner in which the resistance R varies along with the rotation of the shaft is known as tapering. That means when we try to move the wiper in the rheostat or potentiometers, the manner in which the R varies, that is known as tapering. Now let us see the tapering in the potentiometers. So the tapering is effected in order to obtain the different values of resistance. Tapering means basically change of resistance along the length of shaft. Now this tapering can be done in two ways. The first one is linear method of tapering, then it is non-linear tapering, and normally in the non-linear method the tapering used is logarithmic way. That means as we move the shaft or the wiper, the resistance of the potentiometer it changes logarithmically. That means it goes with that of the graph of a logarithm. So here is one method where the linear tapering is implemented. So here we can see that we have taken a ceramic rod on which there is a coil of resistive wire, and when you observe that the diameter of this cylinder is linear, means it is uniform along the full length of the rod or the full length of the device, and the right side is a circular way of implementation of linear type. So let us further see the linear tapering. In linear tapering, the tapered potentiometers, the width of the resistive element is uniform throughout its length. So that's what we have been mentioning in the previous slide as well. So the width of the resistance element is constant. So here you have a graph representing the variation of the resistance along the angle of rotation of the shaft. Or you can as well take the position of the linear movement of the shaft in the type of a sliding type of potentiometers. So here you see almost it is a straight line and the slope is also almost 45 degrees. Okay, so that means it is unity, rather it is very much linear variation of resistance, and that is so in the linear tapered potentiometers the resistance value changes in direct proportion to the shaft rotation. Now let us see the non-linear tapering. In nonlinear tapered potentiometers, the width of the resistive strip changes in a non-uniform manner. Okay. So the nonlinear tapered potentiometers, the width of the resistive element, it changes in a non-uniform manner. So here we can see the size goes on decreasing as you are moving from left to the right. That means from the beginning of one end of the resistive element, as we move towards right, we can see that the width is going on decreasing. Okay. So the width of the resistive element is and this is very difficult to be implemented in the circular type of potentiometers. Now in that, let us see the graphical representation of the characteristics of the nonlinear tapering. In nonlinear potentiometers, the resistance does not change proportionally to the rotation of the shaft. Here you can see in the graph, the resistance is not a straight line. As we are moving from left to right on the x-axis, you can see the resistance value is not a straight line. So it is little linear, then looks like a constant, then goes on increasing exponentially. So that is how a nonlinear tapering is. And here we have shown it as angle of rotation of the shaft. Now let us see some of the applications of these linear or nonlinear potentiometers. The linearly tapered potentiometers are used for TV receivers to adjust the picture height and width on the screen. So here we use a linear type of pot, whereas the nonlinear tapered potentiometers are used as volume and tone controls in audio equipment and also in radio and TV receivers. So here the nonlinear tapered potentiometers are used as volume and the tone controls in audio equipment and the radio and TV receivers. Here the point to be noted is that the nonlinear method is mostly implemented in a logarithmic way. So the volume control and tone control are logarithmically variable parts. Let us summarize the topic covered till now. So in the topic just covered, we have learned the following points. One, we have understood and defined the tapering in potentiometers. Then we have seen different types of tapering in potentiometers, that is linear and non-linear. Then we could see few applications of linear and non-linear tapered potentiometers. Let us see a small quiz on the topic we have just now covered. The tapering in potentiometer means A. Increasing the resistance value, then decreasing the resistance value. Choice C is varying the resistance value, and 4. Keeping the resistance value constant. Which is the right one? It is varying of the resistance value. Next one. Tapering means varying of resistance. Here we should note that we are not telling whether it is increasing, decreasing in any manner, either linear or non-linear. So we are talking only about the varying of the resistance. That is called tapering. Now next one. Linear tapering in potentiometer means choice A, variation of the resistance directly proportional to angle of rotation of the shaft. Then variation, second choice is variation of resistance indirectly not proportional to angle of rotation of shaft. Then choice 3, variation of resistance is exponentially done. Then choice 4, it is none of the above. What's the right answer? It is variation of resistance which is directly proportional to the angle of rotation of the shaft. Well, let us see few frequently asked questions in the examination point of view. Define tapering in potentiometers. What are the different types of taperings used in potentiometers? So linear and non-linear. Then what is the need for tapering in potentiometers? Need means basically to change the value of resistance we need tapering. Next, list the applications of tapered potentiometers. So as we have discussed, it is in televisions, audio receivers, and in some instrumentation as well. Now let us continue with the next topic planned for this session. So the objective of this coming session will be on the completion of this topic. You would be able to learn the meaning of a rheostat. We'll know what is a rheostat. Then we'll also learn about we'll see what is meant by rheostat. Then we'll also learn about the construction and working of a rheostat. And then we'll also see the specifications and applications of rheostats. Let us recap what we have learned in the previous sessions as well. So previously we have learned about the comparison about carbon and wire wound potentiometers. Then we have also understood the need for tapering in potentiometers. Let us see what a rheostat is. The rheostat is a variable resistor with one terminal fixed and the other terminal connected to a wiper arm. So this wiper will be moving along the length of the taper. Next, the rheostats are used to vary relatively large values of current. So the basic difference here will be that will be used to vary the resistance, and you will be having three terminals here. Here we will be seeing only the two terminals. So rheostats are used to vary relatively large values of currents. Now we'll see the construction of the rheostat. So this is how it looks like. So you have a ceramic rod or a tube over which there is resistive wire winding or a coil which is wound along the length of the ceramic tube. Then you have the sliding contact that is fixed onto a support rod above. Then you have a terminal A, B and C. So A and B are fixed value terminals and C is fitted to the wiper contact. And this is how it will be connected into a circuit. And that is you can see here there are only two terminals that are looking into the circuit, that is terminal B and C. That means one is fixed, the other one is on the wiper arm. So only the terminals B and C are used into the circuit and connected to the load. So that means it is going to vary only the current that is being supplied to the load. That is how the rheostat use is. And if you can see the difference between a normal resistors and this rheostat is the size. So the moment you look at it itself is giving an impression that it is a bulky thing. So this is where the difference lies. So the rheostats are mainly used for large current variations or control in applications. So this is what the construction looks like, and let us see a few more types. So this is a fully complete practically available rheostat. Then you have another model of rheostat wherein you can see that whole whole length of the ceramic tube is coated, and there is a small opening which is looking white here, which is looking of white color or a open one, and over which there is a wiper, and that wiper can be moved, and you have seen a nut over there. So it is rather not a flexible wiper, but it is movable, but you can tighten it with the nut. That means a fixed type of a rheostat. So you can fix the wiper along the length at a required position. So these are different types of rheostats. Now let us see the circuit symbol of a rheostat and the differences of that. What is this one? This is a potentiometer. So we can have symbols like this. So that first symbol is a potentiometer, and that is having 1, 2 and 3 terminals. So two ends having fixed value, and the middle is a wiper which is a variable tapping of that. Then the next one is the symbol where you can see only the terminals 1 and 2. That means if you connect a load or the instrument to measure the resistance between 1 and 2, where as you go on rotating the terminal, you will be getting a variable resistance. So that's why it is called as a variable resistor. So here you can see a rheostat and a both cylindrical and a circular model. So a high power toroidal wire wound rheostat. So that is going to be looking like this. You can see the cable on the right side, which is a bulky thing, and we use nuts and bolts to fix the cables to the rheostats. So normally rheostat itself means we are going to use them for high current applications. Let us see few more rheostats with various ratings. So this is looking around 1 inch, and again with some other size. So these are the different models and power ratings. Here we can see the blue one, a normally standard one. Then to its right you have a 2 barrel or a 2 cylindrical rheostat. Next comes a 4 stacked rheostat. That means to meet the current requirements and also the required resistance variations. And there you can see a shaft on the right, a knob that used to rotate that. Then the bottom one green is a rheostat with fixable wiper, as we have seen just previous diagram. So this is another model of rheostat. This is again another one having 2 coupled barrels inside, but mounted on a different way, showing the value of resistance individually on the dial. These are few more rheostats of various ratings and sizes and shapes as well. So the first one is by some manufacturer having 3 barrels, as you can see at the edge here. Then the square ones, there are sliding type, and at the bottom you can see different sizes having different wattages, and they are toroidal coils along with a wiper fitted to a shaft or a knob. So they are rotational type, they are linearly sliding type. And here you have few rheostats with various ratings and sizes. The first one is a motorized potentiometer, and next one is also a motorized rheostat. Then the bottom one is a motorized rheostat with DC motor, is a open frame module. So here you can see everything openly. You have a motor on the right side, then you have some terminals on the left side to connect the to make the connections to connect it into the circuit. And let us see the typical specifications of a motorized rheostat with DC motor open frame module. So that one includes a 125 voltage DC gear motor. Then you have a rotary rheostat within that. The model is mentioned over there, which is T150 model. Then you have 6 rotary cam switches. Then you have 2 end of travel switches, A profile cams. Then we have 3 beginning of travel switches, A profile cams. Then 1 mid travel switch adjustable, B and A profile cam. Then further it is the module is designed for typical specifications for a rotation angle of 300 degrees adjustable. That means we can vary the angle between 0 to 300 degrees. Then you have a cycle time between 36 and 160 seconds, adjustable by a voltage divider resistor. That means to vary the resistance from minimum to maximum, that is called as a cycle, because you have a motor. And that is adjustable between 36 to 160 seconds. So we will see another rheostat with a various rating and size. This is one more different model. Now let us see into the construction of the rheostat. The rheostat is constructed by winding a wire, especially a nichrome, around a former. And normally this former can be circular or cylindrical in shape. So in the previous figures, so the former can be circular or cylindrical in shape. We have seen that in the previous figures. The former is made of ceramic or cement. The wiper blade or the slider is then arranged to touch the surface of the resistance wire and is made to be movable. So it can be movable means in some applications it is sliding type along the length of a straight line, and in some other model you have seen it as a circular type. Then let us see its working. The power is supplied to both ends of the resistive wire and a wire is attached to the slider. The voltage at the so in these applications it is used as a pot. So the voltage at the slider wire is determined by the position of the slider on the resistance wire. So here, by moving the sliding connection along the winding, the resistive wire is made effectively longer or shorter. So this increases or reduces the resistance in the circuit to which it is attached through the wiper again. For the working, if both the ends of the winding are used and the control slider tapping is still connected, then a voltage or potential divider is formed. So that is how it is called as a pot application. And few specifications of rheostats. Let us see the specifications of rheostats. The resistance value varies between 1 ohm to 10 kilo ohms. Power rating is up to 100 watts, and nowadays they are even above that. The temperature rating of the rheostats is this, so they can withstand up to 300 degrees of centigrade, means they are very much robust. Let us see few applications. They are used in heater and oven controls, so they can be at home or industry, bakeries, that sort of places. Then they are used in light dimming control circuits, means actually in some TV studios where there are banks of lightings for shooting purposes. In TV studios or even in movies, they use these light dimming circuits or controls. They are also used in speed control of DC motors, and they are also used in control of arc welding process. So if you change the diameter of the arcing rod electrode, so they vary the current in that. That is a DC application, if you are aware of that. Now let us see the differences between the potentiometers and the rheostats. Number one, so we are comparing the parameter and how it varies in the both potentiometer as well as the rheostat. So the first is number of terminals available. So in a potentiometer you have 3 terminals, and in a rheostat you have only 2 terminals. So we should understand that rheostat is used for current variation and potentiometer is for potential. Itself means a potential divider or a voltage application. And then the variation of the resistance can be obtained by rotating of a shaft in potentiometer, but most of the time in rheostats it is by sliding of a wiper, so it looks rather bulky because of high current involved. Then it is used to tap off voltage, as we have been talking. Pot itself means a potentiometer or potential divider. Then rheostat is used to vary the current. Then where they are connected, so potentiometers are connected in parallel to the circuit, whereas rheostat appears in series with the circuit. Few more differences of these two things, that is potentiometer and a rheostat. So the type of variation in potentiometers, it can be linear and non-linear, but whereas in rheostat it is only linear. Looking at the power rating of the two, the power rating of potentiometer is very low and power rating of rheostats is very high. And the types, So in potentiometers we have both carbon and wire wound types, whereas rheostats involve high current. They are only wire type of rheostats. Now let us conclude this session by looking at the summary of the things what we have seen till now. So in this session we have learnt about the following points. Number one is the definition of a rheostat. We have seen the construction of rheostat. Then we have also seen different types of rheostats available in the industry of different sizes and shapes. Then we have seen the specifications of the specifications and the applications of the rheostats. And of course we have also done the comparison of a potentiometer and a rheostat. Now coming back, let us see some quiz points just to recollect what we have learnt in the previous session. A rheostat is a dash terminal electrical device. How many terminals does it have? 2 or 3? So rheostat is going to have only how many? 2, 3, 4 or 5 choices we have. So it is going to have only the 2 terminals. Second one is a rheostat is designed to handle low currents. Choice A. Choice B is high current. Choice C is low and high voltages. It is used to handle high currents and high voltages. Which is the right one? That is only high currents and high voltages. So it is choice D. So they are mainly used for industrial applications. Now let us see the frequently asked questions in the topics we have seen so far. What is meant by a rheostat? Then describe the construction of a rheostat. That means we have to explain the constructional features of a rheostat, like the cylindrical ceramic tube, copper wire, wiper, and some others are toroidal type along with the wire wound. And then mention the applications of rheostats. So we have discussed now. So they are like used for high currents, speed of DC control, ovens, and some more home appliances like light dimming circuits, then arc welding industry, etc. Then let us talk about the list the specifications of the rheostats. So do you remember any of them? Specifications are high voltage, then high current. What is the range of current or the voltage that can be controlled by using this rheostat? Then you can also mention the type of variation you want, whether it is a sliding type or a rotational type. So these are all coming under the point of specification. So we have also seen some motorized control of rheostats. So there you can see how many types of specifications you have. So it's about the sliding angle 0 to 360 degrees, then how many checkpoints, that means the output terminals you want. Then you also have a specification mentioning about the cycle timings. cycle means in how much time you want to change these variations, or the variations to happen from 0 to your set points. So it is about some few seconds it was there, so it can be up to few minutes as well for the whole value of resistance to vary between the set points. Let us say some set point 1 of maybe 1 ampere current to set point to the end point, that is about say 10 amps for an example. So between these 2 points you want to change the current value. That means we'll be achieving this variation by changing the resistance. So this variation is achieved by using the cycle time in the motor. So by setting this cycle time you can achieve this variation using a motorized control of the rheostat. So these are few questions that you will be coming across in examination point of view.